So I explained the hand layup method. So that is hand means by worker's hand. Layup is stacking together. So but this hand layup method products properties all depend on the operator or worker's skill. So therefore, this is one of the our research about the effect of the operator's skill on molded article quality in the hand layup molding method. So material is chopped glass mat sheet and roving cross, so on. So normally hand layup, when you hear the hand layup, so the chopped glass mat and roving cross, that is the reinforcement, and normally unsaturated polyester resin. So that combination is a common material system. In the hand layup molding method, all processes are performed manually. The person is doing everything. So drawback that physical properties, mechanical properties mold is affected by the skill of level of the operator. So tacit knowledge such as intuition and tips pass on the quantitative techniques from the skilled workers to unskilled workers. Long time to become a skilled worker. So each worker has each technique, his own technique. So my student case, Laura moved from the center to edge and for removing the void air, but some resin bring back to the center. That is one of his skill, his technique. But why do you do this that way? So probably it's very difficult for him to answer that question. So normally his own technique cannot be, workers' own technique cannot be transferred, cannot be informed to the other person. That is a very difficult point. That is a tacit knowledge. So there is a problem that will end up. Therefore, there is a shortage of people without training to skilled workers. So in order to make a training period to be short, so therefore, please do that this way. Please do that this way. That is important. But we need more long-term, long years experience, skilled person's technique. So we should get that technicians. We should hear that technician technique, but that technician cannot say the proper way. So because that is his own way, he does sometimes or often he does not think about the file. So therefore, how to transfer the skilled person's technique to the unskilled person. So in order to transferring the technique, we measured some movement or some technique by using a scientific measuring method. So this is the aim of this research, formalizing the tacit knowledge of expert skill, physical properties of hand layup molded products molded by the workers with different level of skill. So we try to check the mechanical properties of the hand layup molded products by expert, by non-expert, or by beginners. And then we try to understand the difference, and we try to think about the phi. Operation of the molding process of the molded products and the relationship, physical properties, and operation. Experiments. We have 3 subjects, 3 persons, 50 years work experience, 27 years work experience, and 3 years work experience. We call the 50 years person is skilled worker, 27 years workers, intermediate workers, and 3 years unskilled workers. The definition of the expert is a person who has a long experience in a hand wrap method. These listeners of all workers were right hand, so they are right hand. They use the right hand, and the material is unsaturated polyester resin, glass chopped strand mat, and square plate with 400 millimeter and 3 layers stacking. So the unsaturated polyester resin and glass chopped strand mat and 400 millimeter square panel with 3 layers. And here, after glass chopped strand mat, 450 grams per square meter. That means density of the glass chopped strand mat unit. So 1 square meter glass chopped strand mat has 450 grams in this experiment. This 450 become large. That means many glass fiber is contained. That 450 is low to, for example, 300. So that means glass amount of the glass is low. So therefore, finally, if we make same dimension of the composite material, final volume fraction is changed. So when you check which kind of the glass chopped glass mat is used or not, so please check this unit, 400 grams per square meter. So this is a square panel, 400 square, and then the bending specimen is cut out to this part. And this is the bending specimen geometry, width and thickness, and then this is a 3-point bending specimen. And we use an acoustic emission technique, AE sensor. So acoustic emission is used for the understanding the fracture behavior. So the fracture sound comes from the inside of the specimen when we apply the load. So that this acoustic emission sensor, AE sensor, can detect that fracture sound. This is the result of the bending test. This is a strain curve. Left side is expert, right side, middle is intermediate, right side non-expert. Here you can see that some difference in this stress strain curve of the bending. And then in the figures, we show the CV. CV means coefficient of variation of the bending strength data. Coefficient of variation of the strength of the expert is 4.5%, and intermediate person 5%, but non-expert has a very large 11.9%. So the scatter of the strength is very large in non-expert. This is a bending strength and the bending modulus. apparently bending strength is left side, bending modulus is right side. Expert specimen has a higher value than the intermediate non-expert. We use the same material system, same molding system, same equipment. Difference is only technique of the person. But final data, final mechanical properties, strength, modulus, or both are quite different. Expert has a higher. And this is a acoustic emission chart with stress strain bending curve. So the stress strain curve and plus one more line, that is acoustic emission event. So that when you see that point, acoustic emission means fracture occurred. And then we particularly look at the initial part of the acoustic emission activity. So this is the initial part. Line is a stress strain curve of the bending. And then that point is acoustic emission activity is detected. So this is same scale, 100, x-axis also the same scale. So when we can detect the first acoustic emission stress or strain of the expert is higher than the intermediate non-expert. So first acoustic emission event indicate initial fracture stress, initial fracture strain. So the first acoustic emission event stress, initial fracture occurred. So that means initial fracture of the expert is larger than the intermediate non-expert. So therefore, in the case of non-expert, for example, when we apply the load, so the initial fracture immediately start from the beginning. So this is initial fracture stress, initial fracture strain data, expert, intermediate, and non-expert. So the initial fracture strain is high, very high in the case of the expert compared with intermediate non-expert. So normally we try to understand the fracture behavior. This is a fracture surface by using a scanning electron microscopy. So the left side is the expert, right side is the intermediate, center is intermediate, right side is non-expert. You can find out the thermal resin on the fiber in the case of the expert, and in the case of the non-expert, you cannot see any resin on the fiber, and you can see the glass fiber surface directly. And then we observe the more close high magnification. We try to do the more microscopic observation. And then one of the result is one filament, one glass fiber. Around one filament, in the case of expert, there is no void. But sometimes, non-expert, there is a void around the filament. So we can find out this phenomena. So therefore, we performed a more precise observation of the fiber. So this is a fiber bundle for the expert case, and for different specimen. And then you can find out the filament inside of the photograph, and then we try to count the void, how many voids can be found around the filament. So, for example, left photograph shows 182 glass filaments can be observed in this photograph, and then we can see the only one void around the one filament. Next is void 82 void 3, 161 void 1, 64 void 1. So that percentage is the void ratio. Then this is intermediate specimen. Left side, we can see the 122 glass fiber filaments, and we can see the 9 voids. So therefore, void content is 7.4%. And then 105, 88, 10, 82, 11, so on. So the void content is larger than the expert. And this is a cross-sectional photograph of the unskilled person. Similarly, in unskilled person, transmission of the light between the fiber and resin was also confirmed. But so we can see some void, but a very large void can be seen. So why does that difference can be occurred between the expert, intermediate, non-expert? So apparently, until now, we can get data about the void around the filament. So expert void content is very low. Non-expert void content is very large. And then we check that fiber state, filament state. Precise observation of the fiber state cross-section difference in the degree of the opening. So the opening means filament and next filament contacted each other. In that case, we do not say that is not opening. If filament exists in the matrix part individually, that is opening state. So we notice that the opening state is different. This figure shows the enlarged photograph of the cross-sectional observation, while unskilled person case fiber was contact with each other. So the unskilled person, you can see the fiber filament contact each other, and skilled person and apparent to have a slightly open fiber bundle. Intermediate person has a little bit open. And then finally, we try to understand this opening state by using numerically. So this is our definition, measuring the distance between the center of the fiber, each fiber, and then divided L divided by the fiber diameter. So this open fiber coefficient is 1.0. So the fiber state is like this, figure A. So 1.3 is center. 1.15 is lighter. So this parameter can express the opening state. So this is a opening fiber coefficient, X part and intermediate part, non-X part. So this data shows in the case of the X part, fiber filament opened and existed individually at in the matrix. X part coefficient is 1.3 and intermediate person is 1.15. And then bending characteristics differ depending on the skill level of the operator, and a large difference was observed, especially in the initial fracture region, initial fracture stress. From cross-sectional observation, many defective parts, such as the air bubble and defects of the interface, were confirmed in the molded product's intermediate unskilled person. So the interface part, so that there is a void in the case of the intermediate unskilled person. Furthermore, a result of measuring the openness of the coefficient of the fiber bundle, fiber dispersed well or not. X part is a 1.3. That is a very high value than the intermediate unskilled person. This is the result. In order to investigate the difference of these physical properties, working operation during molding is analyzed. Working operation can be detected by this kind of motion analysis. So the workers attach marker was attached to the worker's hand or worker's shoulder or worker's waist or so on. And then by using a camera, so we can get this kind of subject capture camera, and we can get this kind of the figures bottom right. And then with the time, this capture result is moved, and we can understand the movement of the each participant. So this is a roller movement of the each person, expert, intermediate, and non-expert. And this is a roller movement from the side view. So in this case, we can see the U-curve movement can be obtained in the expert. So please see the top part. So the roller moves from the left to right. In this case, left to the middle. So the expert apply the pressure, and that means the distance is deep and go up. So that kind of the U-shaped movement. This movement is a very characteristic movement of the expert. And then we try to think about the fiber state, which is subject to that U movement. Rolling deforming roller, steel roller go past on the surface of glass fiber, without any load, so no change. Glass fiber state is no change. But we apply the load and also the U-shaped deformation state. That means glass fiber filament open. And after that, resin come from the back. So therefore, this U-shaped movement of the expert is related to the opening state of the fiber. So this is one of the conclusions. Mechanical properties were improved by the bending test by operator skill. In particular, there was a difference in the initial count of AE. The skilled person obtained the initial fracture stress about 2.5 times higher than that of the unskilled person. From the cross-sectional observation, the expert was able to form the interface sufficiently, and then fiber bundle was also opened. The expert moved the roller for long distance at a regular interval and made an arc-like movement. I said a U-shaped movement. Here, arc-like movement. As a result, it can be said that the action of the movement, the roller for long distance in the arc affects in the opening of the glass fiber bundle inside the FRP, and the mechanical properties are improved. Results at the moment. But when the filament exists inside of the matrix individually, so of course during the curing stage, matrix is shrinked. So the matrix shrink. So therefore, if the fiber exists in the matrix alone, so the surrounded resin shrink. That means compressive stress applied to the filament fiber. If the opening is not so good, that means fiber get together like this. In that case, inside of the resin shrink. That means tensile load, tensile stress is applied to the fiber. So therefore, interface region become air part, that is a void part. So therefore, related to the matrix shrinkage, filament should exist in the matrix individually. That means filament should be surrounded by the resin in order to not to make interfacial debonding, but fiber get together. In that case, tensile loading is applied. So therefore, interfacial debonding occurred. So finally, we can see the interfacial debonding in the microscopic observation. And interfacial debonding means, before testing, interfacial debonding means fiber and matrix do not touch each other. So therefore, mechanical properties decrease. So the rolling of the steel roller in the hand wrap method, I explained that is an impregnation stage. But that impregnation stage means not only the removing the air from the inside of the FRP, but also the making a good interface. So the hand wrap method, using a steel roller, has two roles. One is impregnation. One is making a good interface. And then finally, expert, that person who can make a good interface, that person's specimen shows the higher mechanical properties. When I asked the expert, how to obtain that skill, your specimen is very good. Your specimen has a good interface. His answer is, I don't know. So this is a very difficult part. During his experience days, years, he do the 100 up, next day 100 up, 100 up. Gradually, he understands the fiber or resin movement or resin properties. But he cannot explain. I am doing this way because he cannot explain. This is a very difficult point. But according to our scientific measurement of the 100-up method, not only the mechanical properties, but also the operator's movement, so that how to remove the void, how to move the roller. One of the simple answer is arc-shaped movement to the fiber, U-shaped movement to the fiber. That make open the state of the filament and make a good interface, make a good mechanical properties products. Okay.